So, one fire ranger stationed at A sees smoke 30 kilometers away. So just take a second to read this over. This question up here is missing some information, right? This should not be here, right? Yours says direction. I was reading it to you and I was like, this doesn't make any sense. In a direction east 30 degrees north. Yours isn't correct? Yours says east 30 degrees north. Mine's missing that, right? Reports smoke 30 kilometers away in a direction east 30 degrees north at B. Okay. And then the next second, a second station. So we've got to take this, and then I'll write it out. So, a second station, that makes more sense, at C, due east of the first station, reports the smoke 20 kilometers away. There we go. Now we have to figure out some stuff. So first of all, I'm going to draw never eat soggy wieners. Okay. We're going to make this our point A. And one fire reports smoke 30 kilometers away, east 30 degrees north. Remember, to use that direction, we would start at east, go 30 degrees towards the north, draw a line, and we know that right here at point B, which is smoking B, 30 kilometers away. The other station, station C, is due east, so it is somewhere along this line, the other station. Station C is somewhere along there, and it reports it 20 kilometers away. So now if we're drawing the triangle and we're going to put a 20 here, the question is, will there be one triangle or two triangles? There's going to be two triangles. Possibly. It could still be 0 triangles. It could be that possibility of one perfect right angle triangle. But most likely, we're going to assume it's going to be 2 triangles. So we'll start by saying 2 triangles since the opposite side is less than the adjacent side. One way that you could draw the 20 is with this blue line. The 20 could be here, and then point C would be there. Another way that you could draw this line, yeah, that's sorry, 20 kilometers. Thank you. The other one could be here, right? The 20 kilometers could be there, and then point C would be over there. So what we do in this case, first of all, we recognize that there could possibly be 2 triangles. Then, to make our life easier, once we figured that out, this diagram is going to get busy on us because it's got a whole bunch of triangles drawn. We then go and draw our triangles out separately. I'll draw the one triangle with the green first. That one looks like this, A, B, and C. We knew this was 30. We knew that this was 30 kilometers, and we knew this was 20 kilometers. And again, we're trying to solve for little b here because we want to know how far apart A is from C. And our second triangle, we'll draw that one out as well. And label everything that we know on that one. This is still 30 degrees. And we're trying to solve little b there. Angle B, we don't know what it is. Nope. It could be, we'll have to figure it out. The only thing we're given is angle A is 30 degrees, and that A to B is 30 kilometers. That may be with a right angle. Grade 10, you dealt with right angle triangles, but this is not a right angle triangle. So we can't use anything from our right angle triangle to figure this out. Yes, Andrew? It could be, and if it was 90 degrees, then both these triangles will come out to be exactly the same. Well, we're going to find that out when we go to solve it. Oh, I should have done this one in blue, because this was my blue triangle. Whoa, easy. Here we go. Select this one. Whew. Luckily, just switch it to blue.
Color change to the rescue.
There we go. Awesome. We are set. So let's separate these two because we're going to have two different solutions. In both cases, we want to find out what little b is. So let's start with our green triangle. What can we solve? Actually, let's start with the blue triangle because the blue triangle is the one that you will solve naturally. The green triangle is the one that you're going to forget about. So we're going to start with the blue triangle. What do we have? Do we have enough for the sine law? And how do we know that? We know an angle and its opposite side. So we know we can use the sine law. What could we solve for first? Can we find little b right away? We can find big C because we have something opposite. Little b we can't do yet because we don't have the opposite angle. So the first thing you can find is C. So we put that on top. That would be over 30 equals sine of 30 over 20. Multiply both sides by that 30. Mental math time. 0.75. Got your calculators handy? Right? You know sine 30, that's one of the memorized ones. That's how you can do it mental math. Sine of 30 is a half. Half of 30 then is 15. 15 over 20 is 3/4. Yeah, good. And so angle C, we do sine inverse. 40.59. I'm going to keep those two decimals. 48. Oh, sorry, that was, just forgot the belt. There we go. 48.59. So now we found angle C. 48.59. I'm going to just write it in a different color in here. I like to use a different color because then it tells me that's something I solved for and everything else was something that was given. On your test or quiz, usually I do the given stuff in pen. If I were you, I would do stuff like that. What I know for sure from the question, I do in pen, and then whatever I solve for, I do in pencil. Yes, Andrew?
Now you can just subtract to find angle B.
Now you can subtract to find angle B. So we get 180 minus 30 minus the 48.59, and we get 101.41. Excellent. Now do we have enough information to find little b? Yes. Okay, little b, whoops, go back to blue. Little b over sine of 101.41 equals, and I'll use the ones that we knew, which was Which ones did we know?
Sine
30 and the 20. So the 20 would go on top. Sine 30. So 20 sine 101.41 divided by sine of 30. 39.2. Well, that's it for this triangle. We've just figured out that this is 39.2 kilometers. So we've solved the blue triangle. What we didn't solve was the green triangle. We know that there's another answer. Now this is what's going to happen in the green triangle. You would start the same way, right? You look at the green triangle, you say, yes, I can use the sine law because I have the 30 and the opposite being 20. And looking at angle C, that would be what I would solve for first. So I would start by going sine of C over 30 equals sine of 30 over 20. Multiply both sides by 30. Do you notice anything similar to this side to the other side? Everything is identical. You get C equals 0.75 and you do sine inverse. And I thought these triangles were different. You get exactly the same thing. But look at angle C. Does angle C look like an angle less than 90 degrees? Okay? That's just the reference angle. Excellent. This is where the ideas we learned in the first bit come into play. Okay? I'm going to go back to this. I'm going to go back to this step right here where it said sine of C equals 0.75. You get so caught up in solving this, you don't even realize when you do the sine inverse that this is positive. That's a positive number, and where, according to the cast rule, is sine positive? In quadrant 1 and quadrant 2. When we found in the blue, when we found the 48.59, that's telling you it's 12. It means I got 3 minutes left. That tells us this angle is 48.59. That's a reference angle.
So we subtract that from 120.
So we would know over here you would also have 48.59. And if you subtract that from 180, you would get 180 minus 48.59, 131.41. So angle C could also be 131.41 degrees. Going back up to a regular one, I'll label that in. And now you could find angle B exactly the same way we found angle B in the other one. I won't show all the work here unless you really want to. You want to see the work? Yeah, you do. So B, first of all, you'd have to subtract to figure out what the other side would be. 180 minus 131.41 minus the 30 leaves us with this angle here at 18.59. So now B over sine of 18.59. Notice that changed from the other side. So we can use the sine law. 20 sine 18.59 divided by sine of 30, 12.75. And rounded to the nearest tenth would be 12.8. Questions for this one? 5, 6, 9, and 14. All the triangles in question 5 are obtuse.